Hello, my dear students. So let's discuss the solution of Open Book Challenge 3.0. Right. So before discussion, let me announce first the physics king of this week. The physics king of this week are Mr. Farhan and Mr. Bora. Right. But these two students are not eligible, although they have given the right answer, but still they are not eligible. Why? Because concept of this question I have already discussed with them, right? And answer given by other students unfortunately are incorrect. No problem, beta. Let's see where you have done mistake. Okay, let's see what is the new thing that we can learn from this question. Okay, right. So first of all, approach in this question is straightforward. So we have to apply energy conservation. So this ball is going down, is coming here, right? So here they are saying surface is rough and friction is sufficient. So if friction is sufficient, it means the cylinder should perform pure rolling, right? So if cylinder is performing pure rolling, work done by friction should be 0, right beta? So work done by friction is 0, so no energy dissipation. So first equation that we can write is energy equation. Okay, so but how many variables are there? Two variables are there, velocity of ball and velocity of cylinder. So we need one more equation. So our approach is very easy, energy conservation, and we need to look for one additional equation, right? Like here what I am doing, first I am doing energy conservation and I will think about one more equation. So by energy conservation I can write net work done by gravity is equal to change in kinetic energy, right? So by that I am getting one equation. So what I need to find, beta? I need to find V2. So just I need one more equation, right? So now in rotational motion questions, we know that there are many different angles through which we need to think, right, for a particular question. So like this question also can contain multiple brainstorming angles, right? So let me discuss what are the different ways that we can look for this question. So first that is angle 1. So angle 1 is generally what we do linear momentum conservation, but here we cannot do because friction must act. So friction will act on the cylinder on the right side. If friction is acting, the linear momentum of the system is not conserved, so that we cannot write. Okay, so first angle will not work. Angle 2, that generally what we think for most of the questions of rotational motion, so we conserve angular momentum. We try to identify any axis about which we can conserve angular momentum. But here, if you think, there does not exist any axis about which angular momentum should remain conserved. Like for example, so when ball is coming down, so you generally what we take, this contact point we take. About contact point angular momentum we conserve generally. But here, so if I am taking cylinder and ball as one system, gravitational force acting on the ball is producing torque about contact point. So angular momentum about contact point we cannot conserve, right? So that we cannot do. Okay, so next thing, suppose I am taking cylinder only as my system, then what will happen? Normal action exerted by ball on the cylinder, that will exert torque, right? So it means only cylinder also we cannot take system to conserve angular momentum, right? So it means there is no such point about which angular momentum should remain conserved, and about center of mass, that's not possible because again friction is acting, right? So generally what we apply in maximum questions, these two things we apply, right? So when these two things are not working, right, then what we need to do? Impulse momentum theorem, right? Impulse momentum theorem means if a force is not acting, what we can do? If a forces are acting, then what we should do? So then we can apply impulse momentum theorem. So whatever force is acting, friction, so for some time dt or delta t, what we can write, this impulse should be equal to change in linear momentum, or better if I will write here integration sign, right? So integration of f dt is equal to change in linear momentum, right? Okay, so similarly I can apply angular impulse angular momentum theorem also, right? So now if I want to apply angular impulse and angular momentum theorem, then what should be our system? Suppose I am taking cylinder and ball as a system. So then So this angular impulse will be a complex thing, because friction is applying impulse, gravitational force is also acting at every instant. So about this point, or you can say this point, right? So if I am taking this as a system, then applying angular impulse theorem also is becoming a difficult task. So we need to do more brainstorming that what else we can do. Now suppose I am taking only cylinder as my system. So if I am considering only cylinder as my system, then what are the forces acting on cylinder only? So one is a normal action by the ball. Now normal action by the ball is passing through center of mass of the cylinder at every instant, right? So that is the special thing in this question, and that is the crux point, right? So the crux point of this question is normal action due to ball is passing through center of the cylinder at every instant. So it means it will not apply any torque. So what are the other forces? Other forces are friction. So if you are considering cylinder only and you are applying angular impulse theorem on cylinder only, so then we can get another equation, right? So if I am writing again, normal action passes through center as I said. So now again I should write integration here. Integration of f r dt is equal to change in angular momentum of cylinder only. So then I can write f dt is equal to mv2. Now this f dt, and from this f dt what I can get, relation between v1 and v2. So by that I am getting relation between v1 and v2. So I am getting v1 as 2v2. So this obtained result v1 is equal to 2v2, that I can substitute here. So here I can substitute, right? So and by solving I am getting answer as under root rg by 3. So this answer I am getting, which is the right answer. So students, if you have doubt in any step in this solution, then please post in the comment section, right? Don't hesitate, okay? Or if you are having a better solution, then also please tell me, okay? I will discuss with other students, right? Okay, thank you bete.